All right, so I'm just going to put decomp over here on the left-hand side. I've actually got more room. Let's just do all these before we get started with predicting products. What about the second one? Is that going to be synthesis or decomp? Yeah, also decomposition because there's just one reactant, one substance. What about 3? It's got to be synthesis. If it's one of the two, we would have to predict its synthesis. Maybe we'll just say synth. What about 4? Decomp. Just one reactant. Must be decomp. And 5? Synthesis. All right. There's some things to keep up with for each of these types. When it's decomposition, we're going to break it up into its elements. Pretty easy, but you have to watch out for your diatomics. If you have a single individual element, or just a pure element of any of these 7 elements over here, instead of just putting down like Br, we always put down Br2. If it's chlorine, instead of just putting Cl, when it's the pure element chlorine, you have to put Cl2. If it's phosphorus, well, it's just P for phosphorus because phosphorus is not a diatomic. So when I break this one up, I'm going to leave some space to balance it, and I'll say plus phosphorus, or yields phosphorus plus Br. But is Br a diatomic element? Yep, it's over there on the list. It's part of Brinkelhoff. It's the Br in Brinkelhoff. So that means whenever I write bromine by itself, when it's not part of a compound, we're going to put a little 2 after it to indicate that. Then you balance. Is this one balanced already? No. I've got 3 bromines on the left and 2 bromines on the right. What's a common multiple of 3 and 2 that would help me? 6. Could I have 6 bromines on the left? Yeah, if I put a 2 there. Then I could have 6 bromines on the right if I put a 3 there. So what's the last step to balancing this one? 2 phosphoruses. There we go. Now it's balanced. So you focus on your individual substances first, then the very last thing you do is you balance it with coefficients. Let's do the same idea on the second one. Again, our pattern is going to be for decomp. We break it up into its elements. What are the 2 elements in hydrogen and oxygen? I just said it. In hydrogen peroxide, there's the answer. Hydrogen and oxygen. So when I put down hydrogen by itself, should I just put down H? What a H2. It's one of the 7 diatomics. Plus, what's the other one I just said? O2. Good. It's a diatomic, and I think that one people are familiar with. That oxygen is O2. Is this one balanced already? Yeah. It is. It's actually wrong in terms of decomposition, but it's right for us today. Hydrogen peroxide actually breaks down into water and oxygen, but we're going to focus on the pattern, breaking these things down into their elements. Next up, we've got a synthesis reaction. With synthesis reactions, you're going to put your elements together. When you put the elements together and they make an ionic compound, like a metal and a nonmetal, you need to make sure your charges of those ions balance out to 0. So for instance, if I were to put together sodium and chlorine in synthesis, synthesis means I'm going to put together the 2 elements. After I put them together, I want to double check my charges. What's the charge of a sodium ion? +1. What's the charge of a chlorine ion? -1. It's -1. +1 or -1, that adds up to 0, and we already knew probably the formula for sodium chloride is just NaCl. I did not worry about chlorine being a diatomic on my product side because that's not pure chlorine. It's now part of a compound. So I focus on my charges to put together my compounds. Then the last thing I'll do is balance the reaction. I've got 1 sodium on the left, 1 sodium on the right. But I've got 2 chlorines on the left and 1 chlorine on the right. Oh, so if I put 2 NaCl and I can fix it with the 2 there, now I've got a balanced reaction. So the first thing I did was I worried about my compound and its charges and its formula. And the very last thing I did was in blue with the coefficients. Okay, 4 is a decomposition reaction. You give it a try. You try 4 on your own. I'll just come around and then we'll do it together afterwards. Try to break that one up into its elements. Watch out for your diatomics. Don't make something a diatomic as an element if it's not already on that list. All right, what's one of my elements that I'm going to get out of number 4? Potassium. Is potassium a diatomic? No. So don't put a little 2 after potassium. If you have a little 2 right there, you need to erase it. It's not supposed to be there because potassium is not a diatomic. What's my other element that I get out of this one? Oxygen. Is oxygen a diatomic? Yeah, so I need the 2 there. Then is this one balanced? Let's balance it real quick. I need 2 potassiums. I need 2 oxygens. So I actually need 4 potassiums, don't I? See, the reason they had to put the 2 on the left-hand side is because potassium's charge was +1, oxygen's charge was -2, and that's part of K2O's formula because that makes it add up to 0. That's when it was part of a compound. When it's pure oxygen, it's a diatomic. If it's pure potassium, it is not a diatomic. All right, last one. Now we've got synthesis. Let's put these 2 together and then check their charges to see, do their charges add up to 0? I'll put together Mg and N. Well, what's the charge of a magnesium ion? Magnesium's +2. What's the charge of a nitride or nitrogen ion? -3. Well, that doesn't add up to 0 yet. So, like we did a couple of weeks ago with ionic compounds, we got to put this together in a combination that adds up to 0. What do 2 and 3 have as a common multiple that would help us here? 6. So I could have +6 if I had 3 of the magnesiums, and I could have -6 if I had 2 of the nitrogens. So with synthesis, you may have to worry about charges coming together to add up to 0 for your product. With decomposition, you might have to watch out for your diatomics. This one should be not too bad to balance. How can I balance this reaction? How many magnesiums? On the 3 magnesiums there. And then the nitrogen's taking care of itself, hasn't it? All right, so that's something I just wanted to go over.